Hey guys, I hope you're having a good day today. This is Grant and I'm back again with another video. Today we're continuing our talk with L'Hopital's rule and indeterminate forms, and I'm just going to give more examples of more indeterminate forms there are besides 0 over 0 and infinity over infinity. So obviously if we get 0 over 0 or infinity over infinity, we can use L'Hopital's rule, which says suppose f and g are functions, and we get 0 over 0 or infinity over infinity, we can take the derivative of f and g and see if we get maybe a determinate answer, right? But there's also more undeterminate forms besides 0 over 0 and infinity over infinity. For example, there is 1 to the infinity, that's 1 to the power of infinity, 0 to the power of 0, infinity to the power of 0. There's infinity minus infinity, and 0 times infinity. These are the indeterminate forms. And it's important to note, if you get an indeterminate form that is not 0 over 0 or infinity, i.e. one of these forms, you need to convert it into a form that is 0 over 0 or infinity over infinity before you can use L'Hopital's rule. If you're taking some limit, and you get, let's say you get 0 times, we'll say, limit, sorry about that, limit as x approaches b. Let's say we get, I don't know, this is f of x times g of x, right? And let's say we get 0 times infinity. Well, we can't just take the derivative of f and g, because this is not 0 over 0 or infinity over infinity. L'Hopital's rule only applies to 0 over 0 and infinity over infinity. So with that in mind and all these other indeterminate forms, let's do a quick example. All right, here we go. So example, let's take the limit as x approaches infinity of e to the x plus x to the power of 1 over x. Okay, so seems easy enough. Let's see what we got here. As e to the x plus x goes, as that goes to infinity, that will increase without bound. So that's infinity. And 1 to the power of infinity, to the power of 1 over infinity, well, as that approaches infinity, that will reach 0. So we have infinity to the power of 0. That is an indeterminate form. Now, we can't just take the derivative of this and this. We have to do some stuff to get it into a form that is 0 over 0 or infinity over infinity before we can use L'Hopital's rule. So, a fancy little trick here, what we can do is we can examine e to the x plus x, 1 over x, and we can say, well, let's raise this to the e times ln power. And the reason we can do this is because just the way that e and natural logs work, right? If we have the number 3 and we raise this to the e to the ln of 3, well, the e's and the ln's will cancel, and this will just be 3. So 3 equals e to the ln of 3. These are both the same number. So that's why we can do this. We converted this into this. And this should be more... should be like that, right? Okay, so that's all fine and dandy. So now, because this is a natural log, we can convert this and say, okay, we can move this out front. We can say this is e to the 1 over x, ln, e to the x plus x. Excuse me there, running out of room. So that's our new equation. We're still taking the limit as x approaches infinity. Okay, this is interesting because the e doesn't affect it, so we can kind of more or less forget about it for now and just examine this part. And if we examine this part, examine that part, well, it's just ln e to the x plus x over x, because it's 1 over x. And when we plug this in, we should get infinity over infinity. Okay, that's awesome. Now we can use L'Hopital's rule. So we're going to take the derivative of the top and the bottom. All right, let's going to move that up here. So the derivative of ln e to the x plus x is just 1 over e to the x plus x. 1 over that times the derivative of that. Well, that's e to the x plus 1 over the derivative of x is just 1. So this is ultimately going to be, we can put that on the top. All right, and we're still taking the limit as x approaches infinity. Well, this is still going to be infinity over infinity. So we can take a derivative again. Derivative of the top is e to the x. Derivative of the bottom is e to the x plus 1. And again, we'll get infinity over infinity. One more time, and we will get e to the x over e to the x. And you might be thinking, well, if we plug that in again, we'll get infinity over infinity. Well, e to the x over e to the x, that's just equal to 1. That is just equal to 1. And the limit as x approaches infinity of 1 is just 1. So that's why that is 1. But be careful, because 1's not our answer. We must raise 1 is the power. 1 is this. So the answer is really e to the 1. So the answer is e to the 1, or just e. And that is our answer.